I want to focus on the first two slides. I've got a few slides here, but I really want to start out with a deeply important issue, which is explained here with this idea of no one will trust AI without explainable AI. I should actually backstep and say thank you to you and to Ragnar and to Petra for having me again. I love Hamburg. I love the show, the conference. It's not my first rodeo here. And I just, thanks to them, have a new office with them in town. I was just in Hamburg, and I want to be coming back there soon. So Hamburg is a big favorite town of mine. So with regard to this idea, this actually is a perverted quote from a friend of mine, Mike Clayville, who's the chief revenue officer at Stripe, big company. And he's probably one of the best guys at business model understanding of anyone I know. And Mike said, no one will buy AI without explainable AI. And I've perverted this a little bit to no one will trust it without explainable AI. This is probably the most important idea, I think, in computing today. So what does it mean? What it means is that, as we all know, GPT world, let's call it, GPT enterprise, has a lot of great things about it, but of course, one bad thing, and that is we cannot know, because it's made of neural networks, how it did what it did. And we cannot know whether, therefore, what it did was true or false, safe or dangerous. And we are at the brink of being forced to give up on the idea of trustworthy computing. And let me tell you, that would be a mistake. I think you're all smart, you're all tech people. You know that we can't give up on trustworthy computing. So what's the answer? And here's what the answer isn't, Sam Altman, CEO of OpenAI. Guardrails is not the answer. Guardrails is important and fraudulent as a concept. It's important because everyone's talking about it, because everyone accepts that the technology itself is dangerous and flawed. That's important. But it's fraudulent because you cannot solve the problem, in neural networks with guardrails. Won't work. There is no safety there. So we have a bit of an enigma. And how do we solve that for ourselves and for our customers and our partners, And the answer is not going to be get rid of GPT. The answer is going to be something different. And what you hear from Eric Schmidt and what you hear from my friend Elon Musk and others is you have to have interpretability, you have to have explainability. And I'll just jump to one more very important part of this idea, which is now everyone agrees on what I just said. Unfortunately, they don't have it. And their alternative is to market it with hype anyway. And so I'll use IBM as an example. IBM, having dumped Watson, still sells Watson, and having never had explainability, is selling explainability. Well, stop it, just stop it. So every company today is saying they have explainability. What they really have, if they were being honest, is what we call hinting, things around the edges of a neural network that will help you explain roughly some part of your understanding, but certainly not a deep understanding of how that system did what it did to make a prediction. That's the true definition of explainability, and it's important. Now, let's see if I can click. No. Can you click? And if you cannot click, I will just keep, there you go. Great, okay. So what I'm trying to say here is that we're going to make up some new words, new theories, new ways of talking about explainability and of pattern discovery so that we can move beyond the cage, almost a jail, that was imposed upon us by neural networks and the black box problem. So the black box, I think everyone knows here, it means basically you just do not know how or why your system did what it did. And we call that learning to learn. And to be effective in this conversation, several years ago, we published a paper, which is online. You can see it at our website at patterncomputer.com, with 35 co-authors from the national laboratories and Cambridge University and Yale and elsewhere. And about 5 of our people are mathematicians. And what it said was, here is a specific mathematical definition of explainability. If you're going to claim you got it, you have to meet this definition. IBM, pay attention now. So they can't. But it's useful because when you can, then you can actually learn from the operations of your AI system. And that's not only a great help to the earlier problem I mentioned of the fails with regard to GPT and neural networks, but it's much more importantly a positive thing. You can actually learn about what you're looking at in a deep way, which you couldn't with prior tools. And I'll spend some time on that in a minute. So we call that turning the black box into the glass box. And we think it's both agnostic and powerful. You'll see we've used it in a variety of areas, including drug discovery. We've built the world's most effective COVID detection system. We have 4 different flavors of explainability, and we have a program called Powered by Pattern. It's general, it's disruptive. We can use it in mining, we can use it in cancer, we use it in manufacturing, quality control, healthcare. It just doesn't care. It works in everything we've looked at. So this is a general idea and a disruptive idea, which is not only helpful, but revolutionary. And it's revolutionary not only in business, but in science, which we explain in that paper I mentioned. So you see this word discovery theory. We've actually been working pretty deeply on the idea of how is science affected when we have true explainability. And it's a big deal. We take the scientific method because of this for the first time, and we can flip it so that instead of having a hypothesis at the beginning, you're not allowed to. And instead of that, you start pure data. And then from pure data, you gain your hypothesis. It literally is a reversal of how the scientific method works. And not only does this save lives, it saves time and money, saves resources, and it helps you make money. So all this stuff is beyond neural networks, I would call it. And all these things lead to major discoveries that were not available under neural networks alone. And it's true in science, and it's true in business. Next slide, please. Thanks. So here you see 3 big boxes. This is what we've been up to lately. So, use cases, proof cases is part of what we wanted to talk about this morning. And this is here in very rough form. We are doing a thing called Project Starbright. It's the top 5 cancer killers in the world. And we're doing something either drug discovery, diagnostics, or analytics that will move the needle on saving lives from those cancers. And I'm really proud of this. I'm going to come back to it in a minute. We have a different thing we call Project Python. It's now called Prospectral, and it is the most rapid system in COVID detection, the most accurate system, the cheapest system. So 2 drops of saliva, I'll tell you more about it in a minute, but it is really an amazing thing. And it's partly through work with both the national labs at Berkeley and at Los Alamos. And then finally, Explainable AI. So these are the 3 things that we're doing that are really big things, and all of them fit this idea of having to have explainability to do the other things we're going to talk about doing. Next slide. Here are some of our 13 current pipelines, and they keep growing month by month, as an example of what you can do with explainability that could not be done before. And so we are not cancer experts, or we weren't, maybe we are now, but we had these great tools. And the result was we were able to make discoveries in drugs for breast cancer. Here you see that, ovarian cancer. So we have 2 new drugs in triple-negative breast cancer, 5 new drugs in what's called high-grade serous ovarian cancer. We're about to file another slew of patents in prostate cancer this month, in July, actually. So we'll have another probably 5 new drugs there. We have already done work in lung cancer, about half finished, and more to come. So this is working. And all these tests where you see these green check boxes, we don't do these tests. Usually it's Charles River, which is probably the top testing laboratory in America, if not in the world. So it's not us saying that these things kill cancer or arrest its growth. It's outsiders. And I'm saying this because, look, it really works. We're now beyond the argument stage of whose stuff is better than whose stuff. No one's done this kind of thing before. Next slide, please. Here you see a little bit more. We're working with the Fred Hutch Cancer Center in colorectal cancer. It's great. You know, all these things are working fine. I got to keep going because I don't want to run out of time. But what we're doing is we're creating 5 new drugs every month that are novel and patentable against the top 5 cancers. Next slide, please. Next slide. There we go. This just shows we can find synergy. These combo drugs we're making really do work. This slide, that's okay. Go ahead. Keep going. That's a heat map of synergy for ovarian cancer. Next slide. And this is our device. The exciting thing here is you're seeing the various areas of how it works, why it works. What's going to happen next is we're now testing for 20 diseases with the same box. So imagine 3 seconds of test, 2 drops of saliva, using light alone, no chemicals at all, no PCR, probably $5 a test retail cost, and 20 diseases and growing. I think this is going to be really disruptive. Next. It works, as I mentioned, everywhere: aerospace, oil and gas services, genomics, minerals, other things we're doing. It's really exciting. It really doesn't care. The system is truly a general platform, and the ideas behind it are general in nature. So I'm saying all this, you can tell that I'm passionate about it. This is where we've got to go. It's not about our company. This is where we've got to go theoretically. We need to get beyond the idea of GPT alone and live in a GPT enterprise world, which is better controlled and informed by our own knowledge of how and why our systems are doing what they're doing. Next slide. And in summary, here you go. So we're not saying GPT is bad. We're just showing how different GPT is from what it is today to what we need as a society and group of mathematicians and so on tomorrow. And we need to have the how and why. We can't rely only on neural nets. And if we do this kind of thing, we'll make major new discoveries, incremental ones, which is what we get out of neural networks. Next. Great. I made it a little over time.